Why build APIs? We can just use all the tools out there. If you haven't bumped up against this problem, you probably don't see it yet, but the problem is tool sprawl. I've suffered from this a number of times, and it's when you start to build a bunch of point to point solutions that you're delivering to people. It starts with maybe RPA, then we have a little bit of Python here. Maybe we're bopping over to Vercel, we're using a bit of AI on the back end. We throw in a lang chain, we throw in a llama index. Now we pipe it over to Pinecone. Now you have a bunch of different tools. They all have their own documentation. They all have their own snowflake way that you have to deal with them. Maybe you're building a flow to respond to customer emails. Maybe you're building a simple flow that's going to produce a newsletter for you. Whatever it is, it's now become insanely complex with all of these point to point integrations. How do you take all these point to point integrations and make them easy to access and also something you can iterate on over time? It's really just throwing it behind an API endpoint. And don't take my word for it. A lot of these companies have done this already. They've come to this conclusion a long time ago. If you're at the consumer layer, you won't really find these APIs anywhere. Even in the enterprise layer, you start to pops up in a couple places, but these companies tend to keep their APIs internal. Where I'm seeing all these APIs pop up is in this prosumer layer. And in that prosumer layer, you'll have access to generate videos, social media things. You can generate a bunch of images. So it's starting to become more normalized that these companies expose an API that end users can use, and they want to zap things over here and zap things over there. Now, if you look at the broader landscape, that's going to be the opportunity for this. I'm pulling up the 2024 MAD diagram from FirstMark. They list out so many different tools here, and I can bet that a lot of these will have some type of API interface available. So taking a complex workflow and then putting it behind an API is going to not only boost your productivity, it's going to allow you to share out your work with a broad number of people. Because guess what's happening now? People are dealing with a lot of decision fatigue and a lot of broken processes. So they don't want another complex process for you to lob over the wall for them. They want something they can consume really quickly, like an API endpoint, and maybe they can throw into their workflows. Also for you on your own, maybe you're building something with Zapier and it's turned into this massive spider web of things. You can take a lot of those steps and turn them into a single endpoint. The example we're going to try to go with today is I want to get AI news quickly, but I don't want to really sit and watch all the AI news. There's almost too much of it, and I spend so much time watching AI news. So I'm going to build myself an API endpoint to do that. It's going to be pretty simple. I'm going to take a definition first approach. This is not unique to me. A lot of companies do this. AWS has Smithy, so let's pull that up quick, where they can quickly, a couple lines of code, they can get back a service and an API. Microsoft actually recently announced TypeSpec, which is a similar idea. And you can see here that they're creating a TSP file that defines a couple services, and then they're getting back an open API specification. And Google has gRPC, which they came up with, and Qlang, which is really under the radar. I don't think a lot of people use this, but it's a configuration language essentially, and you can do a lot of things where you can generate schemas, you can generate protocol buffers, you can even generate that open API specification like we mentioned before. So the idea is to adopt this approach for yourself. Instead of wrangling a bunch of tools together, start thinking in terms of services, start thinking in terms of what APIs can I package up all these workflows together. So once you have that tight feedback loop of defining some type of use case, you nailed it down, and then you have some tight iteration between defining that use case, building it out, and then sharing it, that's going to make your life a lot easier. So let's continue with this example of building out a YouTube tool that can, get us the AI news. I'm sure you've built something way more complicated than this by now. We're going to map out the key functions. We're going to avoid using vendor-specific tools for our lo-fi design. And then we're going to make sure we understand our security posture for this. So let's start with the security posture. It's not that serious. I don't think anyone's going to hack my YouTube tool, so we're okay with using managed platforms. We're okay with not having all the super tight security controls for this one. And then we're going to talk about the two different components of this. The first one's going to be the actual data pipeline I want to set up. So the data pipeline is going to be super simple here. I just want to download the transcripts from the YouTube videos, and then I want to format them and then save them to some disk somewhere that I can access later. Then we're going to set up a simple ragbot. And this ragbot is going to have its own vector store in memory, so we don't have to reach out to any third-party tool to house the data. Of course, the performance is not going to be that great if we're doing it in memory, but for the example, we'll let it slide. And then we're going to have a model provider that we hit, likely going to be OpenAI in this case. We're going to have some type of function that reaches out to the model and then comes back with a response. So one thing here is we're going to have an agent GPU container. I don't want to run this on my local desktop. I want this to run in the cloud somewhere. So when someone hits that endpoint, I don't have to worry about spinning up a VPS, or I don't have to worry about maintaining a server. It just gets spun up and then spun down when the person's not using it. So the last step here is to become GPU rich. You want to understand the build effort involved with the APIs you're building. You want to stay away from really high vendor specific knowledge requirements unless you're purposely using that platform. If I'm going with AWS, that means I want to have tight security controls. I want to have high performance in some certain areas, and AWS managed services are going to do that for me. Then we want to consider like the maintenance of the entire system. So you could spin up a VPS, throw your API on there, but it might require you to manage a GPU on your own or a cluster of GPUs. That's a whole different commitment versus if you use a managed service platform to just handle the GPUs for you. And the final one is thinking about adaptability, which is a proxy for how easy is it for you to change? Can you change on the fly and get it up and running again? Or is it going to be a 1 to 2 year session for you to get this stuff working again if all your requirements change? So quick little visual on this. If you go the hardware specific route, I'm not really a hardware guy. I don't have servers I manage or anything like that. But I think vendor specific knowledge will be close to none because you have your own server. You can do whatever you want with that. There's no imposed opinion on how to do things. And the maintenance effort again would be a little bit lower. Say it's a single GPU. As long as you understand what you need to do to keep that GPU alive, it should be okay. Now, if you're managing clusters of GPUs, that's a different story. And security controls, you're going to have your own security controls you can implement there, but you can only do so much if you're one person or if you're a small team and security is not your main thing that you're doing. So the managed platform is going to have a completely low build effort, and vendor specific knowledge is going to be a little bit higher. Maintenance effort here at 0. What I really mean is I don't have to worry about the server. Like I don't have to think about it. And I can just call it when I need it. It goes out of existence when I don't need it. So that's great. Then the security controls, you're not going to have as much control over security because the platform should come built in with the security that you want. Of course, there's going to be a couple little things you have to do here and there, but overall, you should not have to worry too much about it. Then let's go with the cloud solution. The cloud is going to take up the most effort. It's also going to require the most vendor specific knowledge. You're also going to have to maintain it. So if you build a bunch of EC2 instances, you have to maintain that. But if you maybe go with more serverless managed options, the maintenance might come down. And I have security controls at the highest level here. It's really up to you how much you want to invest in that security part of it. And if you want to use all the managed solutions for security, that's great. You can also build some of these stuff bespoke from scratch if you really want to. Just keep in mind you want to become GPU rich. So you don't want the GPU to be your bottleneck anymore. When you start to think about API endpoints, you want something that you can spin up quickly, spin down when you don't need it, or at least you have your own hardware that's at the right specs that you don't have to be doing model quantization and on all that type of stuff. So that's just going to really slow you down. So let's jump into the code here where we're going to set up that tool that we're going to use to kind of scrape AI news and get back a quick summary from a chatbot endpoint. Then we're going to take that endpoint and put it into a RPA tool. So you get this feel for, all right, we took a really complicated thing, but then we made it available over an endpoint. And now we can quickly just use it in one of our flows. Remember, we're taking a definition first approach. And why I picked a couple of these tools is because it embodies this idea. So Modal was developed mostly for data teams, but it just so happens that they really nailed this generative AI use case. And they're able to power a lot of things like AI inference, fine tuning, and batch processing. They're used by a ton of folks. So some big highlights here is Cursor, Substack, Cognition, which came out with Devin, the AI software engineer, Suno Labs, which is like the music generator thing. So a lot of people use this. And one more call out is Scale. And Scale is used by OpenAI, almost all of the big players in this space. So these guys are heavy hitters. So using their platform is a safe bet. They also take security pretty seriously. They have a set of really good security protocols that they follow. And you can read this at your leisure, but they have a couple of compliance things they do as well. It's a perfect platform as like a jumping off point to using something like AWS or one of the cloud providers. Okay, so that covers modal. If you guys want me to do like more of a deep dive tutorials and stuff on that, I can. But I think you probably have already used it. We're also using Fast API, and Fast API helps you build APIs quicker with Python. You also get some documentation out of the box, so I won't cover that. There's a lot of information on Fast API available. I'm assuming you are comfortable with Modal and you've read through some of their documentation, so I'm not going to cover exactly how Modal works, but I want to take you through this approach, which is that definition first approach. The first thing we're doing is we're defining our application here. Then we're creating our like Fast API wrapper. Then we're going to define our storage. That works in terms of when you spin up the app, it'll create that volume for you. I pass this parameter here, create if missing equals true. That means if there is none, it'll create it, but if there is one, it won't overwrite it. So next up is the containers. So this is where you don't have to deal with Docker. I can simply just describe the container I want. So what I'm doing here is I'm just defining a Linux container with Python 3.12 installed, and then I'm going ahead with a pip install command that installs the libraries I need for this specific container. This is going to be the data image container, so that's where we're going to run our download the YouTube transcripts and save them to storage somewhere. The next one is going to be our agent image. Here we're doing the same thing again. We're creating a Linux container, and then we're installing all of our Python libraries we need for this project and within this agent image specifically. Okay, so let's talk a little bit about the data pipeline. So within the data pipeline, all we need right now is to use that container image, that data image. We want to have a location to to download our transcripts, and then we want to run some type of schedule. So making sure this runs at 5 a.m. every day. And then it'll call our load YouTube adapter with this AI news search term. So it'll go ahead and do all that work on the back end. Now this is where I want to define the actual API endpoints. And we just have one here, which is going to be that chatbot endpoint from earlier. And we're going to have it reach out to that ragbot that is going to do querying. So this ragbot's going to be naive. It's just going to have a vector store in memory. And from there, be able to give us an answer back based on those YouTube transcripts. So a little bit of boilerplate we have to do is defining the asynchronous API and then returning it back. So giving it a complete definition here. I want this to run again on our agent image. We're going to have that same volume. We do want to be able to reach out to OpenAI, so we're going to have to give it a secret. And then I have here that the GPU is going to be any. So this is a really cool function of Modal. This is how you become GPU rich, technically. And all I need to do is define what GPU I want here, and I can have that GPU, provided it's available. There's a couple scheduling things. This makes it way easier than trying to run this specific code on the GPU on the cloud, and then run this over here on the CPU, and I need to try to quantize this. I can just define in my code which pieces need a GPU and leave it at that. Okay, so next up, let's dive a little bit into each of these pieces here. So if we go into the data pipeline, we'll see that it's really calling this use case. And this idea of use cases is what I've carried over into my code. If you go into YouTube transcripts, get YouTube transcripts, this is the use case essentially. So what it does is it'll create a writer instance. It'll clear the cache. So I don't want old transcripts. I want all the new transcripts. So we're going to clear the cache first. And then we just do some work to search YouTube and download those transcripts and save them to that location. So pretty straightforward there. If we go back to our main file, The next one is the RAG bot. So if we go into our RAG bot here, all this is a adapter calling a use case, and within the use case, we have something called our lazy RAG agent. And that's where I'm doing a lot of the heavy lifting. We're creating a index store here, and then we're returning back this chat engine. So Llama Index is doing the heavy lifting for us on this end. And what I like about Llama Index is it's actually wrapping the chat engine for us using an agent. So if we go down to the code here, let me make that easier to read. You'll see that they have an agent runner and it's returning an agent runner with this query engine tool. And that's what's doing the work for us on the back end. So we don't have to mess around with writing the end-to-end chunk this, do that, do this. It's just pretty easy to call it. Of course, if we wanted to optimize this process, we would have to get to the low level of RAG. But for this example, I'm assuming you've done RAG stuff already. You can optimize that if you want. All right, so let's see how this runs. Let me pull up my terminal here and actually deploy this. So let me deploy it. Okay, so it's been deployed now, and we have a API endpoint that's available for us to actually hit. So just from that quick definition, a couple of functions here and there, I have my API endpoint ready to go. And of course, this is not like a unique process to modal. I want you to not focus on the tool specifically, but the idea that I defined it, then I got something back that's an API endpoint for me to use downstream. If we jump into the dashboard, so let me jump into the dashboard here and go over to the app itself. So you'll see I'm on version 5. So I've deployed this a couple times. I had some things that weren't working, made them work. And let's look at our data pipeline. So I can see the logs associated with this. I can do some basic observability stuff. And now if I really wanted to run this flow, you can see it's set to run at 5 a.m. UTC time tomorrow. So that's in 5 hours from now. I could actually just kick off my data pipeline right now. So let's go ahead and kick that off. And you'll see that it takes about maybe 5 to 8 seconds to really run this stuff on startup. And then the actual execution is about 30 seconds. It's pretty slow. It's not optimized. The idea is I could optimize this if I wanted to. As a simple example, I'm just going to let it run this way and be okay with that. So let's let that run. And once it succeeds, we'll then go ahead and try to interact with our API endpoint. So that succeeded. And you'll see that about 2 minutes ago, I ran that entire process where it loaded the transcripts for us. And we'll see here that there are a couple of obvious news stories that are probably popular right now, maybe not popular when you watch this video, but Microsoft has a new massive AI. Stephen Colbert's popped up here. AI music generators, like the typical suspects here. Nothing super surprising. So we ran a query to ask what is the latest AI news related to Microsoft. And if we look at the response from our API, we'll see it says Microsoft is preparing to launch its own new AI language model called MAI-1, I don't know how to pronounce that, which is being developed in-house, which is pretty cool. So we've done a couple of things here, which is we've gotten some latest YouTube video that came out on this topic. We've saved a transcript. We've now added it to our own repository, created a vector index on it in memory, and then had our chatbot reference that vector store index to give us back a response. It might be trivial for you to do this now, but this is essentially a complicated process where instead of someone having to know all that stuff, they can simply just use an API endpoint. Okay, to further drive this point home, I set up a quick workflow using Pipedream as an example of how you can now start to really save yourself a lot of time, but also share out some of your work here. So I took the API endpoint I developed and just threw it into one of these RPA tools. And so what we're going to do is run this now, and we're going to take a quick look at the configuration. And the question I'm asking is, what is the latest AI news related to Microsoft? And so we should get a response back that gives us an answer specific to the transcripts we've downloaded from YouTube previously. And we have a response here. So Microsoft is set to launch its new AI language model called MAI-1. Still don't know how to pronounce that. Developed entirely in-house, led by Mustafa Suleiman, who previously worked at Google, aims to have about 500 billion parameters. All right, so cool. Now we have a way to get AI news without sitting on YouTube watching videos all day. And I can even run this to maybe spit out a summary to like a Notion file, Google Doc, something like that. So we can do a lot more with this rather than just a simple RAG chatbot. Overall, we've accomplished what we set out to do, which is we went from a bunch of tools like this and back to just having a simple workflow. We defined our use cases, we built what we needed, and then we shared it with downstream consumers. We can even put this in apps, we can put this in APIs, we can put this in RPA tools as well. So if you're using something like Vercel, for example, Vercel has a let me see if I can find it. Vercel has a modal integration as well, so that's probably one of the choices I made. Of course, it integrates tightly with Vercel, so if you're trying to go to Vercel, that's pretty easy. Modal also actually works with AWS too, so you can just add in your AWS secrets, and you can even bring in images from AWS specifically. So it's pretty neat how if you make some upfront decisions, you can really save yourself a lot of time and a lot of headache. If you go with this define first approach, you'll have a better time than trying to really navigate this market of a bunch of different tools and trying to stitch things together that are not meant to work together at the end of the day. Hopefully this was helpful to you. If you want to see anything specific, let me know in the comments below and I'll see if we can prioritize that.